Hello and welcome to this video on task delegation. In this video, we'll be covering task delegation, essentially how we can delegate specific tasks for execution on specific targets. With task delegation, we may have a requirement to run specific commands or tasks on either a control host or another host. In this video, we're going to be using the facts derived from our target hosts, and we'll be designating this information to a specific host so that it can open TCP wrapper rules accordingly. We'll restrict SSH access so that it only works from Ubuntu-C, CentOS 1 and Ubuntu 1. Let's get started. Okay, so I'm in the Dive into Ansible Playbooks deep dive, and in the task delegation folder. If you step into revision 1, and if we take a look at our playbook, in this revision we have 3 plays. In the first play, we're creating a dedicated SSH key pair that we'll use for Ubuntu 3. You'll note at this point, we're using the Ansible user, as this is running against our control host, Ubuntu-C. In the next play, we're copying our newly generated SSH key pair to all of our target systems using the Linux group. Whilst doing this, we're specifying the owner of root, and we're specifying the permissions through the use of with_together. So, the private key will be set to 0600 and the public key will be set to 0644. In the third play, we're implicitly running against Ubuntu 3 and we're installing the public key using the authorized_key module. Again, this will be as the root user according to our inventory. If we give this a try, okay, so that's generated the SSH key pair. That's copied the file to all of the hosts, and we've added that to our authorized keys file. Step into revision 2. And if we have a look at the playbook here, we have an additional task there at the bottom that is going to invoke SSH from the command line to check if SSH connectivity is successful. This is using -i and the identity, which is our private key. Batch mode is an option for SSH that will allow SSH to just fail. A fingerprint or key is not accepted. We saw strict host key checking earlier, and if it wants to write to a known host's file, we're telling it to write to /dev/null, as we're not concerned with keeping the fingerprints. Root at Ubuntu 3 is our user and host, and quite simply, we're running the date command. The command module is always going to invoke a change, and we're more concerned with whether or not this access is open. So we've used changed_when as false for this to show a green output if SSH is successful. Lastly, ignore _errors is true, as we want this task to be informative only. Let's try this out. Okay, and we can see at this point that this has been successful. Let's go into revision 3. And if we take a look at the updates, we have 2 new plays. In the first, we're actually making use of delegate_to, which is essentially the main focus of this lesson for task delegation. We are in essence gathering the facts on our hosts Ubuntu-C, CentOS 1 and Ubuntu 1. Then we're telling it through delegation to add a line to /etc/hosts.allow on Ubuntu 3 using those values. After adding that, we're checking to see if we can still SSH. At this point, we should be able to, as we've only added allow rules. No deny rules exist. Let's try this out. Okay, so far this is working as expected. Step into revision 4. And this is where this gets very interesting. We have 2 new plays, and within these, we're adding a deny all rule. We're then rerunning our SSH check. At this point, if the host isn't in the allow file, it's going to be rejected. Okay, perfect. So you can see there that it succeeded for Ubuntu-C, CentOS1, and Ubuntu1, as these are all in the etc/hosts.allow file. It's failed for CentOS2, CentOS3, Ubuntu2, and Ubuntu3, according to the deny all rule. Lastly, let's go into revision 5. And in this one, we've got the addition of 2 new plays. These are essentially our cleanup crew. We've reused the previous tasks, but we've changed to the state of absent to remove the entries from the etc/hosts.allow and etc/hosts.deny file. When we run this the first time, it's going to fail, as the initial SSH tests are going to be impacted from the previous time we run this, and at present those hosts are still denied. But afterwards, we should be able to rerun this revision as many times as we like, and it will go through the entire cycle with connectivity being open at first, the connectivity then being closed, and then the connectivity being reopened. So let's run this twice. First time. Okay, so here we'll have the failure. And again, we're going to get the failure again. Yep, third time failure as well. But now we're actually running the removal of those entries. So this time when it actually runs through, it should work as expected. Let's give that a retry. Okay, great. So all of those are open. We've added the allow rules. Should still be able to connect. Yep. Now we've got the deny rules there, and it should fail. And then we're doing the cleanup. And if you were to try this again, it would work as expected each and every time. Okay, so I hope you've enjoyed this example for task delegation alongside the Linux aspects with TCP wrappers, and again, the power of Ansible to manage aspects like this. Please join me in the next video, Magic Variables.